G'day viewers, just going to make a small video about photons. A lot of confusion apparently out there in the metaverse. So what do we know about photons? Well, they're an electromagnetic phenomena, and we can easily make photons from any alternating frequency, where we can generate a radio wave or such, or a light wave, source of light. So let's just get into it, and we'll say that the wavelength is equal to the speed of light over the frequency. And we know the speed of light is 299,792,458 metres a second. So the simple formula is we reduce our frequency in megahertz, so we divide that by 1,000,000, we end up with 30, and we divide the speed of light by 1,000,000 and we end up pretty close to 300, so that's close enough. So a frequency of 30 megahertz is approximately 10 metres. Now, as some of you will know, resonance occurs in odd multiples of half wavelengths. So the first resonance structure we can build is a half wavelength structure. And if we centre feed that with a say radio frequency of, that's what we call HF, high frequency, 30 megahertz into a centre-fed half-wave dipole, it will look something like this. And that'll be 2.5 metres, and that will be 2.5 metres. So we've got two quarter wave structures put together, centre fed. We put a AC signal into there at 30 megahertz. And if it's vertically polarised like that, we end up with vertically polarised electromagnetic waves, which we divide down into photons. And each photon, the measurement, the power in joules of a photon is E equals simply HF, where H is the Planck's constant and F is the frequency, and you'll end up with the joules per photon. And then the joules per photon divided by the frequency is the joules per second per photon. Anyway, we won't discuss the structure of space-time. I've got my own theories on that, which, as I said, this whole picture is a giant jigsaw puzzle, and I have built over the years my own jigsaw puzzle out of it, and energy, time, space, mass, everything fits in. But what we're going to do is look at how the photon is created and the current and the electrical force distribution in the dipole. And it's very simple, very, very simple, and easily explainable. If that's our dipole there, this here is the current distribution, is like that. So you've got more current at the centre, and as you're progressing up the dipole to either end, your current drops off until right at the end it's next to nothing. But the opposite occurs with the electrical field, and I'll do the electrical field in red just so that you've got no, so we'll put here positive and over here negative. So you've got no ambiguity. And this is the voltage distribution. Goes like that and goes like that. That's the current and voltage distribution on a half-wave dipole, and as we see, it's vertically polarized here, so that will give us vertically polarized photons. If you rotate it horizontal, obviously the polarization is reference to the electrical field lines. So the difference between going horizontal to vertical or vertical to horizontal, there's a 20 decibel conversion loss between polarities. Horizontal to vertical polarity, 20 dB. That's 1/100th of your signal can be captured using the opposite polarization to what you're transmitting on. Now, how the photon travels through space, this thing here, and because it's massless, it doesn't experience time. The only time it experiences is during its generation and its reabsorption at the other end. Now, if this photon is 10 meters in size, how does an electron generate a 10-meter photon? Well, it's quite simple. All the electrons in the antenna structure work together. So they cause a alternating current to perturb a perturbation in space, and space has the property of it. It's a superfluid, in my opinion, that tries to remain at zero average. So if you pump a positive energy into the space, it will collapse back to zero at the speed of light, and if you pump negative energy into the or negative voltage and current into the space, it will also collapse back. So you've always got this pressure where it's going out, collapsing back in, going out, collapsing back in. But the photon does not lose energy over distance. And what it does, it can be stretched, it can be slowed down relatively by receding masses or by difference in relative velocities between objects. You get that Doppler effect, and that occurs with photons. You get them red shifting or blue shifting, depending. If you're moving towards them, they'll blue shift. If you're moving away, or if they're moving away from you, you get them red shifting. But the thing is, what is the internal structure of the photon? I would ask anybody that, even the greats like anybody with a degree in physics, especially somebody like two people I respect. There's Neil deGrasse Tyson. I would ask him, what's the internal structure of a photon? And what about Sir Roger Penrose? I would ask him the same question, and can they answer it? I have my own answer already. I have given clues of this in previous videos, but let's look at the receiving end of where the photon lands. And you've got an antenna here. This is your receiver. So that's where you want your AC signal to form. The only way for a photon to convert from its structure, and I'll say its structure is purely magnetic, but with a voltage component. You need the voltage component because that's what gives it the energy, and the magnetic component is what gives it the voltage. It's really weird. It converts voltage here into magnetism. It travels through space, and as it's coming here, the field is travelling this way, like that, generating a positive. And if it's travelling back this way, oh, hang on, how's that work? Yes, exactly, how's it work? The magnetic field is still travelling at the speed of light this way, but the field orientation is going this way to create positive and this way to create the negative. And as you go through the halfway mark, this reverses, this starts going this way. This is after halfway. and then this one starts going this way, which generates the opposite half. So that's my opinion on photons. I've had a few years of designing and building different antenna structure. And how do we build antenna? Well, we use wavelength and we use formula. We don't use the number of photons. We do, however, consider the current going into the antenna. And up here we see that the free space is 300, free space impedance is 300 ohms. And the best antenna are 300 ohm antennas. It's very hard to achieve. Generally we use 50 or 72 ohm, 75 ohm coaxes, and a half wave dipole, as we drew before, a half wave dipole, make that a bit more even. Now, generally this we calculate this to be about 98% of the half wavelength. I'll do that a bit better. It's a horrible lambda sign, that one. So, can I get this right today? That's better. So 98% of the half wavelength, and this is because at the end of the dipole structure, the last little bit is made up by air, believe it or not. The voltage is that high, it actually makes it look, the capacitance on the end makes it look like this antenna is a little bit longer than what it is. So we use the formula 98%, and that is very close to being perfectly acceptable for the antenna. But then we start calculating if we want to turn this into a Yagi-Uda array. It's a funny thing about that, these Japanese guys, two professors in Japan, designed the Yagi-Uda, where they had a reflector and a director. And the reflector was slightly longer and the director was slightly shorter. And you would have seen antenna like this, old TV antennas. Now what happens, this is roughly a quarter of a wavelength, or I'll put a quarter there. We actually don't use a quarter, we probably use 0.2, 0.15 depending. And this one here you can have a quarter again, but generally we'd use 0.2, 0.15, 0.1, depending on the impedance matching and depending on how you build your centre element, whether it's folded dipole or whatever. Or we use a gamma match to match the impedance, and that comes in at about 20 ohms, and then we use a matching apparatus and it makes it up to about 200, sometimes 300, depends on how they're matched. But this, the wave comes here, reflects off here, and then it adds. So you've got basically a quarter, and then a strange thing happens when it hits there. It flips 180 degrees. So you've got basically 360 degrees. So you're adding another wavelength going that way. And what you'll get with an antenna like this is probably something like a 6 decibel gain, 6, 7.5 tops. And that is about a 4 times power increase. So your electromagnetic wave field is basically concentrating all your photons. These are called a beam antenna, into like a beam, and your main radiation is that way, like that. And we'll draw the pattern. It's something like this, and you'll get these little side lobes like that, and then you'll get little back lobes like that, and you'll get a small lobe there. So, but you'll get most of your power going forward. You'll see these in amateur radio installations, and that's basically how they work. If you hear a lot of people out there talking about photons and waves, a lot of them really have no idea. They've done no practical experiments. They really don't know what they're talking about, and it's a pity that they're leading a lot of people astray. So I'm just putting this out there just so you know that I've got a little bit of a clue. So that's about photons. They travel at the speed of light. They're easily destroyed. You can deflect them. You can deflect them as proven by Einstein and his rings and all that sort of thing. If you hear anyone raving on about the Eddington experiment not being done for the last 400 years, it's been done. It was the first time they did it, they didn't get the right results because of poor equipment. And one result turned out fairly good, and the second experiment wasn't done properly. They did it again like 4 years later, and it confirmed Einstein's theories. So yeah, there's some misinformation out there, but the only thing you can do is really study it yourself, and watch some qualified people that can talk about that. So that's my little rave about photons and how it excites space. Well, this thing, I just call it space. And we know space has properties, not the devoid space outtime our universe where nothing exists, but space within our universe, what we call the space-time continuum, is a fantastic study area. And I've come up with my own theories, and they're sort of panning out, and I've sort of been beating them into shape over many, many years, and I've got some, well, you could say some excellent results. Not that any people will believe me or listen to what I'm saying, so we won't go on about that in this video, but I will do another video pretty shortly on energy. And see, there's another thing. Nobody understands what energy really is. I'll tell you what it is. Even the great Neil deGrasse Tyson, he's a brilliant man. You should watch his videos. He's got a lot of informative videos out there that will tell you a lot. But when it comes to energy, I don't think there's many people that know what it really is. And when you find out what it really is, it will blow your mind. It will, honestly, if some people just listen to me, I could add to the discussion some valuable information. What I'll do in the future, I'll be making some videos on synthesizing diamonds, how you can make diamonds. Very easy. I did this like 30 years ago. Not that it got me anywhere, but the education and the information I gleaned from the experiments is beyond any normal realm of value. It's invaluable, the knowledge that I gained. Space-time continuum and gravity, you should really study that and see if you come up with what I've come up with, and the energy flow and how it works. And we're right on. You think all the things have been discovered, and I've heard people say, "Oh, it's not worth it. Everything that's been discovered, you can't discover anything new." And oh no, we're a long way. We're pretty primitive when it comes to what's left to discover. For example, I'll make an outrageous claim is by using what I've just drawn on the board, we can reverse gravity. It's not actually anti-gravity. It is it's more of an inertial drive system, and there are practical demonstrations out there in space right now that I could say, and this is how it works. But anyway, that's in the future. I'll make a few interesting videos. I hope you like this little one on photons. That's about all I've got to say. Just check your sources and see how qualified the people are that you're talking to. I've got years of experience with this, and I always pass my exams that I have to do. So yeah, thanks for watching. Cheers and beers and all that. I'll catch you on the next one.